Hello people of Triple Science Physics, and welcome to my second lesson on rotational forces. The first lesson I did was about moments, levers and seesaws, so if you haven't seen that, maybe you want to have a look at that one as well. I split it into two lessons because that's normally what I would do if I was going to teach it in lesson. So we're going to be concentrating on looking at gears today. So I've highlighted here in the objectives what we're going to be looking at. So what do gears do and how can we use them in calculations to look at mechanical advantage, and I've highlighted as well describing situations where forces can cause rotation, because obviously it fits in with the with this idea of rotational forces. So the first thing I'd like you to do is just have a think. Do you know what a gear is? Can you think about why gears are used, or maybe think of a couple of examples where you might see gear being used? So the definition of a gear is that it's a rotating machine part, so it's either got cut teeth or it's a cog, and it will mesh with another part that's got teeth of a similar size or the same size, and they will transmit turning force between each other. So you can see here there's just a simple animation of two cogs. They're both rotating, got these teeth together. They transmit the turning force from a bit of extra information that you really need sort of a view of ideas that are able to change force in concentrate, but also important to notion that they are moving, and we'll talk about that in a little while, and also change the speed. So even so, they can do a couple of videos showing you examples different of gears. The main thing that I would talk in most looked at laws and physics is that use them to get an advantage. That with this left force one in this book because it's very closely related. We added bone look at these, and so out the diameter of the gear as well, and how this relates to the number of teeth and the advantage they can. In this first example, we've got two gears, just a simple example. We've got the small gear here on the left and the slightly larger gear. It tells you information. First of all, the teeth are all size half the same size, or else they wouldn't lock properly and connect wouldn't work very well. So all the gears are the same size, teeth on the gears are the same size, and that means for each click on the small gear, you get a click on the larger gear. So I always like to think of it to how some of the. So in here, that example, the small got teeth that clicks in the second gear that has 20 teeth. So what it's in here is that if the large gear goes around one small gear twice, in the large gear you've got 20 clicks, little gear that's going twice, 20 click, 2 rotation the teeth. So just pause though and have a look at the questions and what with. So in the question, it's if the gear's got teeth, a large gear 40, how many times would the large gear rotate? If the time small gear teeth around times into 8 clicks within the gears. So if we think about 8 clicks, the gear have 2 teeth. I mean, the 3 clicks that would go around twice. So the answer to the question is twice. Thinking of clicks, I think, is a really nice way of keeping it simply brain. Talking about how the locking gears are moving in relation to each other. Well, they're moving in directions, opposite directions. If we were to add another on to the larger gear, that would turn in the same direction as the first gear. So the kind of as you add gears. So here we've got small gears clockwise, therefore the larger gear turn anti-clockwise. Here's a slightly different question format. So it's got two gears here that are for interlocking, and it's saying that rotations pass from the large gear to the small gear, so from this large gear here to the little small gear at the side. The large gear's got 60 teeth and the small gear's got 20 teeth, so pause the video and have a look at these 3 questions, see if you can work out the answers, and then come back, compare. Okay, so the first question is saying, how many turns will this small gear make if the large gear turns once? So if the large gear's got 60 teeth and that turns once, that's 60 clicks. If you've got 60 clicks with 20 teeth, that's going to go around 3 times. So for the first one, you've got 3 turns on the small gear. For the second question, if the large gear is rotating when the small gear rotates twice, how much rotation are you going to get on the large gear? Well, if the small gear rotates twice, that's 40 clicks. 40 clicks is 2/3 of 60, so you're only going to get a 2/3 of a turn of the large gear if the small gear rotates twice. And then for the last one, how many times will the small gear rotate if the large gear turns twice? So the large gear's got 60 teeth. If it goes round twice, that's 120 clicks on the teeth. So 120 divided by the 20 teeth is 6. So that means that the small gear is going to do 6 turns when the large gear turns twice. Okay, so here's another practice question. It's telling you that gear A's got 15 teeth and gear B has 45 teeth. I know it doesn't show that in the picture, but that doesn't really matter. It's telling you that gear B is making 60 turns in a second, and it wants you to work out how many turns does gear A make in the same amount of time. So pause the video, have a go, and then come back for the answer. Okay, so if gear B has got 45 teeth, and that means that if it's going to turn 60 times, then the number of clicks that you would get would be 45 teeth times the 60 turns, which gives you 2,700 clicks in with gear A. If gear A's got 15 teeth and we've got 2,700 clicks, if we do the 2,700 total clicks divided by the number of teeth, that gives us 180 turns. So 180 turns compared with the 60 turns that gear B makes. So gear B is bigger, and that means it's going to make less turns in the same amount of time. Okay, so here's a slightly different question, and it's using ideas that you learnt about last lesson when you looked at turning forces and moments, when you looked at levers and looked at how to calculate the moment or calculate the turning force. So here it's telling you that gear A has got a radius of 0.12 metres and gear B has got a radius of 0.21 metres, and that gear A is being turned by a force, so it would be an external force that's turning gear A with a force of 14 newtons. And the question's asking you to use calculation to show how this gives a mechanical advantage, so you can pause the video and have a go. Okay, so if gear A is being turned by a force of 14 newtons, what we need to know to be able to do this question is that the teeth on gear A apply the same force to the teeth on gear B, so the force is the same. So if we use the information to calculate the moment for gear A, you've got the force times the distance. So if we do that, we get 1.68 Newton meters. We do the same for gear B, you've got the same force but a slightly larger distance, so that means that you end up with a greater turning force on gear B, which is the larger gear, for the same force. This slide here is just looking at speed or time taken to rotate compared with the number of teeth. So we're looking at 3 gears here operating together. It's saying here that the central cog is being driven by the external force, so it could be somebody pedalling or it could be a water mill or something like that, and that the blue and red cogs are being driven, so the 10 and the 15 are being driven by the 20 in the middle, just in case you're not very good at seeing colour. And it's saying that the blue cog is taking 8 seconds to rotate, the red's taking 12, and the grey cog is taking 16, or the middle cog is taking 16 seconds. Describe the relationship between the number of teeth and the time taken. Well, if you've got a larger number of teeth, then it's going to take a longer time to rotate. So here we've got double the number of teeth. 20 is going to take double the amount of time to rotate. So the larger gears are much slower than the smaller gears that they are clicking with. Okay, so for this last question that we've got, I actually took this question, or part of this question, off a past exam paper. So have a look at the information and have a go at the 3 questions, and then we can go through the answers. Okay, so for the first question, it's asking the candidate to describe how gear P would move compared with gear Q and include information about direction and speed. So you need to say 2 things. So for this first one, you've got gear P would move anti-clockwise. So if gear Q is moving in this clockwise direction, then that is going to push gear P to move in the anti-clockwise direction. Because if you think about it coming around like this clockwise, it's going to push down, it's going to push P in the anti-clockwise direction. And gear P is also going to be moving slower because it's larger gear, it's going to take a longer time to rotate, so it's going to be moving more slowly. Then for question 2, give the ratio of the number of teeth on gear P. So you've got 24 on P and 16 on 3, and if you divide both of those by 8, you get the ratio of 3 to 2, so 3 relating to P and the 2 relating to Q. And then for the last one, gear P is making 4 turns. So gear P is the one with 24 teeth. So if you do 24 times the 4 turn, that gives you 96 clicks. And then if you divide the 96 clicks by the 16 teeth, you end up with 6 turns. Okay, thank you very much for watching this short lesson on gears. If you haven't watched the part 1 lesson on moments, looking at seesaws and levers, then give that a look, and I'll see you soon.